All right, let's talk about one of the most mind-blowing, absolutely wild reactions in all of chemistry. It's called the oscillating clock, and you're about to see why it seriously looks like pure magic. So imagine this. You mix a few totally clear liquids together, and what you get? Well, it seems to break all the rules. The solution changes color, and then it changes back, and then it changes again. I mean, how is that even possible? Are we watching sorcery? Or is there something way cooler going on at the molecular level? Okay, so what you're actually seeing is something called the Briggs-Rausher reaction. And on the surface, it looks like it's violating a basic law of the universe. You know, the one that says things always get more chaotic and disordered over time. Yeah, this reaction seems to create order from chaos, and then it does it again and again. Let's break down the play-by-play because it's awesome. It starts out totally colorless, then bam, it flashes to this brilliant amber color. Before you can even really register that, it suddenly flips to a deep dark blue. And then, just like that, it's clear again, all ready to restart the whole show. It is an absolutely mesmerizing loop. Now, think back to any chemistry class you've ever taken. You mix chemical A and chemical B, and you get C. That's it. The reaction goes one way, and it's over. But this thing? This goes forward, then backward, then forward again. It actually oscillates. So the huge question is, how on earth is that happening? Well, the secret isn't magic at all. It's actually a super fierce chemical tug of war that's happening right inside that beaker. You've basically got two different processes, you can think of them as two teams, battling for control over the exact same ingredients. The official sciencey term for this is an oscillating reaction. It's just a fancy way of saying you've got a system where the amounts of certain chemicals are rising and falling in this really regular, repeating pattern. And lucky for us, we get to see that pattern play out as this incredible color show. So this whole chemical fight comes down to two competing pathways. On one side, you have a radical process. Think of this as the super fast, high-energy, aggressive team. On the other side, you've got a calmer, non-radical process. Now, when the high-energy team radical is winning, the solution turns amber. But when the more stable team non-radical takes over, it flips to that awesome deep blue. Okay, so here's how the cycle actually works. First, Team Radical comes out swinging. It consumes a key ingredient and turns the liquid amber. But in doing so, it uses up its own fuel. So as Team Radical gets weaker, Team Non-Radical sees its chance and takes over, turning the solution blue. But, and this is the absolute genius part, the reaction that makes the blue color also creates the very ingredient Team Radical needs to get back in the fight. So the battle just resets and the whole cycle kicks off all over again. But wait a minute. If it's a cycle that fuels itself, why does it ever stop? Right? Why doesn't this clock just keep oscillating forever? Think of the whole beaker like one big fuel tank. At the very beginning, that tank is totally full of all the chemicals needed for the entire war. During the middle phase, the fight between Team Radical and Team Non-Radical is at its absolute peak, and the color changes are super fast and dramatic. But, eventually that main fuel tank runs dry. So the reaction doesn't actually break down or fail, it just finishes. The death of the clock is really just the moment that the main fuel tank hits empty. The tug of war is officially over because both teams have finally run out of supplies. So what's the big takeaway from all this? What we've been watching isn't some trick that defies the laws of physics. Nope. It's actually an incredibly elegant example of physics doing its thing. It really illustrates a core truth about science. So many things that look impossible or like straight up magic are usually just a peek into a much more complex and frankly more beautiful set of rules that run the universe. And this reaction, it's one of those amazing windows. So no, it's not sorcery. What it is this breathtaking dance between competing chemical pathways. This is thermodynamics in action, the science of energy and entropy playing out right there for us to see. It's just a stunning reminder that the real rules of the universe are so much more intricate and amazing than we often imagine. Seeing it explained is one thing, but watching the real deal is something else entirely. So, you ready to see it in all its glory? Check this out.